Yes, class. Am I audible to all of you?
Yes, ma'am.
Sabiha, Shaima, and Jasleen had their classes. Hafsa, this is your first class, Hafsa, right? Hafsa?
Yes, ma'am.
All right. So I think the timings issues were there. I think Jasleen also was not comfortable with Saturdays and Sundays. So I think this time we'll be having the classes now. So the classes will be now on Monday and Wednesday instead of having it on Saturdays and Sundays. So since last week we didn't have any class because of the shift in the timings, let's quickly recap whatever we have studied. What about? Zainab has also joined. Zainab, did you receive that link of the class?
No, ma'am.
Still you haven't received?
Ma'am, I got the notes, but it's showing error.
The notes are showing error? Okay.
Yes, ma'am.
Did you inform this to the team?
No, ma'am.
Zainab, just to do one thing, Zainab and Hafza both, share your email ID in the chat column. All right, so we had started with dimensional analysis, and dimensional analysis is not a very, very lengthy topic. Let us at least complete its first part. That is formation of dimensional formula. At least we can do that formation of dimensional formula. So in this, we had studied about the physical quantities. What were the physical quantities? They were divided into two groups, fundamental and derived. The quantities which you could measure. So fundamental were which were originally present, and derived one which were used using the formation of fundamental quantities. Fine. So in the system, we have basic 7 fundamental quantities which you should be aware of. And with the help of these 7 fundamental quantities only, we'll be using and forming the dimensional formula. So the dimensional analysis chapter, this is divided into 3 parts. The first part is formation of dimensional formula. Like you should know how to write a dimensional formula if an unknown quantity is given. All right. Second part of the question, second part not of the question exactly, second part of the chapter is formation of equation. If variables are given, will we be able to form the equation or not? That is the second part. And third part is conversion of unit. All right, so these are the 3 parts in which your syllabus of dimensional analysis has been divided. So at least let us complete the first part. 2 classes have already gone. This class, at least we should be able to complete the first part. Now, how to write the dimensional formula? I hope you all remember, those who were there. Those who weren't there, for you, I'm just repeating: mass, length, time, temperature, current, luminous intensity, and amount of substance. These are 7 fundamental quantities. That's why I'm asking for the mail. I'll share this part. I hope now error shouldn't occur. I'll share again it. So we have to write everything in terms of this. For mass, we write it as M, L like this, T like this, and if any other variable comes in between, we'll keep on adding. 2 supplementary quantities were there. Plane angle. Plane angle means the angle formed in 2 dimensions. Solid angle means angle formed in 3D, like the angle that is formed in a cone. That is 3-dimensional.
Ma'am, from supplement angles, I didn't write the notes. I don't have the notes.
Yes, Sabiha?
From supplement angles, I don't have the notes.
From supplement, you were not there in the last class.
I left ma'am in middle because of my flight.
Acha, you were traveling, no, Sabiha, in the last class?
Ma'am. Yes, ma'am.
Then share the email ID in the chat column. Okay, Sabiha? Then derived quantity, yes. So how to write the dimensional formula? This is the first task. See, you have to write everything in terms of MLT. If no mass is present in the formula, your power of M will be 0. If no length is present in the formula, length will be 0. Time is not present, time will be 0. If the quantities are present, we'll put the powers as 1, 2, 3, and so on. Like we started with this example of area. Area is length into breadth. So length multiplied by breadth. For length, we can write it as L. For breadth also, we can write it as capital L. So this becomes L square. right? This is L square. So if this is L square means mass is 0, L is 2, T is 0. This is what we call as the dimensional formula, writing of the dimensional formula. All those students who were not there or who have left, like Sabiha, you left the last class, take the video lectures also. All right, just I'll also inform the team to share the video lecture also, the link with you, especially Hafsa, you have to take 2 classes also. So at least you'll have an idea what we have done. So volume will be L cube, and some more quantities we discussed. So these were some important quantities that we had discussed. Physical quantity, displacement, velocity, momentum, force, and all this. So how to write the formula? Let us continue that. So all those students who were not there, they'll also have an idea how to complete this. See, the first quantity, 7 quantities we have discussed, and about those 7 quantities, I have already told you that learn those. Like for energy, displacement, power, learn all those values. See, for distance, remember distance formula. Distance is simply length. Velocity will be distance divided by time. So this will be the formula. Or when we're talking about displacement, displacement will be, velocity will be displacement by time. That is distances formula by times formula. So we get the velocities formula. Now, what is important here is you have to remember the velocities formula. Why? So that this will be helpful when you will be solving it. Suppose you see this example of acceleration. Suppose acceleration is velocity by time. So if you already remember the formula of velocity, the dimensional formula, it's easier, right, to solve. So I'll be sharing this with the other students also. Please, at least till all these quantities, try to learn. Distance, you already know it's L. Try to learn speed or velocity, acceleration, force, work done. These 4 at least you remember. These 4 are very helpful if you remember. Pressure and rest, you will be able to figure it out yourself. All right. So let us continue with this. So 7 quantities we have discussed. Some more quantities. Let us start. So in between, we'll be practicing questions. Now, what is angular displacement? And for angular portion, you already have a all right, for your examination. When we are talking about, we'll be studying it in detail. As I've told you, many of the lessons that we are going to study or we are studying, these chapters that are included have separate chapters on their own. Like if I talk about acceleration, velocity, the next lesson that we'll be starting, motion in a straight line, it is comprising only of velocity, acceleration, and all. Then we have a separate chapter about force. So do not worry when we are talking about these quantities. Right now, your focus has to be on formation of dimensional formula. You should just be able to write the dimensional formula. That's it. Formula will be given to you in the question this time. So what is angular displacement? We have a chapter, rotational motion, that is torque. Your rotational systemic particles is there. So torque, force, your force becomes torque. Your every quantity that is present linearly, that becomes an angular motion. Like if I talk about displacement or distance, distance is in a straight line. When we are talking about the rotation and that distance covered in rotation, that becomes angular distance or angular displacement, like this. So it's enough to keep in mind. Right now we have to focus on the formula. So formula is length of arc by radius of arc. Now class, how to write the dimensional formula? Length of arc. How can we write the length of arc? Length of arc by radius. Radius, how do you measure? Whenever you are getting confused in which fundamental quantity we should substitute the value, measure it. Radius, how will I measure radius? Radius is also a length. My voice is not coming. Voice. Just let me know now. I have changed the connection, so I hope this is better. All right, now my voice is coming properly.
Yes, ma'am.
All right. See, I was saying when we are talking about angular displacement, the formula is length of arc divided by radius of arc. How do we write the length? Length is written like this, L within the brackets. Radius, whenever you are confused how to write some quantity in terms of fundamental. So what you should do, you should simply think how will you measure it? Like radius. Radius is actually the distance. It's actually the length of the half of the circle, right? So this will also be L. So length gets cancelled. That is, this is dimensionless. The angle has no dimensions because length and length both get cancelled. But unit is present, that is radian. So a very common question that comes in the exams is that mention the quantity that is dimensionless but has a unit. So best example is angle. Angle has no dimensions, but unit is present. All right, there are quantities which do not have unit also, but angle has a unit, radian, we know that. Come to this angular velocity. Now, rate of change of displacement, that is angular displacement with respect to time, that is angular velocity. Again, I am repeating, do not focus on which physical quantities are these, how we have obtained the formula, nothing. You have separate chapters on these, you will be studying this. Right now, your focus should be on how to write the dimensional formula. See, angular displacement. What is the dimension of angular displacement? Angular displacement was L to the power 0. It was dimensionless, nothing was there. While time is T to the power 1. So when this time will go up, it will become T to the power minus 1. That is the dimension. And SI unit, this is radian per second. All right. Come to angular acceleration. Now, what is angular acceleration? Again, the acceleration in rotation is angular acceleration. What was angular velocity? Angular velocity was T to the power 1. And what is time? Time is also T to the power 1. Sorry, this is minus 1 and this is T to the power 1. So when this T will go up, minus 1, this becomes minus 1. So minus 1 becomes minus 2. T to the power minus 2. So this is radian per second square. Write down these three, especially Hafsa and Sabiha. If you have any doubt how to write these, then just let me know. I'll repeat that part. Other students also write, then we'll complete this statement. All those who will complete writing till the 10th point. See, moment of inertia. This is a quantity that is related to your mass in rotation. The way you have mass in your linear motion, for mass in rotation, we use the term moment of inertia. So formula of moment of inertia is mass into square of radius. The formula is mass into square of radius. All right. So tell me the dimensional formula for moment of inertia. Yes, class. Answer for the 11th one. Mass into radius square. It's very easy. See, mass is formula is m. Radius square. Very good, Shaima. Correct. ml square. See, mass is m. Radius is length. Radius is just the length. So L square, when we write it as L square, radius square means length square. And is there any time in our formula? No. So this simply becomes t to the power 0. This is the dimensional formula. All right. So we write this as kg meter square SI. One or two quantities let us discuss. Torque. Torque is basically the force in rotation. The force that we talk about, friction force, any other force, that is in normal linear motion. Translation, simple, moving in a straight line. But when anything comes in rotation, that is known as torque. So torque's formula is radius into force. Now see again, force is coming. So force, velocity, acceleration, distance, these are very basic physical quantities that will be used in most of the formula, maximum formula. All right. So that's why it's better that you all remember force at least. So what is radius? Radius is again length multiplied to force. Force is mass into acceleration, right? So what this will become? Formula will become m L square t to the power minus 2. This is the formula of torque. And SI unit is Newton into meters. All the SI units, it's not compulsory for you to remember. Whichever units you can remember them. Otherwise, just remember the basic SI units of the 7 quantities. That's enough. Right now, this should be clear how to write the dimensional formula. See, angular momentum when we are talking about. This is linear momentum multiplied to radius. See, this is radius. What is P? P is linear momentum. So momentum also we have discussed. Momentum was mass into velocity. See, what is the radius? Radius can be written as length. What is linear momentum? Linear momentum, if you check in the table, all those students who were not there, you can leave. Other students who were present, we have written linear momentum. That is mass into velocity simply. So mass into velocity. This is the formula. So what is the final formula for angular momentum? M L multiplied to L. That is L to the power 1 into L to the power 1 becomes L square. And then what is left in time? T to the power minus 1. Right? So see, when we are talking about the SI unit for angular momentum, this becomes kg meter square per second. First, tell me all of you, till these 13 quantities, are all the 13 quantities clear to you? Hafza, you tell. Are you able to decode how are we writing the dimensional formula? Yes, Hafza. Yes, no. You there in the class, Hafza?
Yes, ma'am.
Are you able to understand this?
Yes, ma'am.
Okay, any difficulty, please let me know. Sabiha, what about you? You are able to understand?
Yes, ma'am.
Jesleen, you were also absent in the class, last class. It's clear?
Yes, ma'am.
And Zainab, Shaima, clear to both of you?
Yes, ma'am.
All right, then
Ma'am,
write
what
it.
is the SI unit for angular acceleration?
What is the
SI unit for angular acceleration?
angular acceleration is radian per second square. This is radian per second square. RAD is radian. This is per second square. All of you, please answer this 14th point, stress. How will we write the dimensional formula of stress? Okay, so some of the students have answered. Shaima has answered. Zainab and Sabiha have answered. Sabiha, Zainab, answers are correct. Shaima's one error is there, just one error in your answer. Rest is fine. See, what is force? How do we write force? Force is mlt to the power minus 1. That is velocities, ml to the power t to the power minus 2. That is mass into acceleration divided by area. Area is L square. That means this is 1, this is 2. So look, when this 2 will go up, it will become minus. See what we are left with. Mass is m. This is fine by all of you. L to the power 1, L to the power 2. That is 1 minus 2. What is 1 minus 2? 1 minus 2 is minus 1. So L to the power minus 1. Or you can look at that way also. 1L will be cancelled. So only one length will be left in the denominator. So it will be L to the power minus 1. And what else? T to the power minus 2. So just this one, otherwise rest is correct. Yes, so talking about stress has the same formula as pressure. So this is pascals, or we write it as Newton per meter square. Some quantities related to this, you can copy it later. Let me discuss these first. So this is actually from your bulk modulus. This is from your book 2, all the topics that we are discussing. Strain means whatever is the change in length by the original length that is present. So change in length means length by original length means again length. So they will again get cancelled. This will be a dimensionless quantity. Now, what's special about strain is that this has no unit. So if a question comes, these types of questions are there in your exam that mention the quantity which has no dimension but has a unit, which has no dimension but has no unit. So when dimensionless and no unit, that is your angle because it has a unit. And when this is dimensionless but has no unit, this will be your strain without unit. Your angle has a unit, that is radius. All right. Now, modulus of elasticity, just look at the formula, that is stress by strain. So stress, the answer which you all gave, that is m L to the power minus 1 T to the power minus 2. And strain is nothing, L to the power 0, nothing. So this will again be the unit of stress only. M L to the power minus 1 T to the power minus 2. SI unit will also be same, Newton per meter square. Surface tension is force per unit length. This you all will answer. Surface. Let me discuss these. Wavelength, time period first. What is wavelength? Wavelength is basically length. So length will be L. That's it. SI unit, meters. Time period is time. So this is T, which is SI unit is seconds. What is frequency? Frequency is 1 upon time. That is reciprocal of time period. That is 1 by time period. So when this T will go up, this will become T to the power minus 1. That is seconds inverse, or we have one more unit, that is hertz. No need to focus on this. You will be studying this. Though this frequency part you will have in your chemistry also right now. Structure of atom, there you will study this. Planck's constant, and how much, what else? Planck's constant, let me discuss. Then you can copy till here 21 and then tell me the 17th point that you will be answering, surface tension. Then I'll be writing it and completing it. All right. So Planck's constant is this H. Now what are all these quantities? Let me first tell you this. E is energy. Remember I told you something about energy, that the dimensional formula of energy, work done, all these will be the same. All right. Energy is work done, any type of energy, potential energy, kinetic energy, all these will be the same. So energy's formula will be the same. H is the Planck's constant, which we have to find out. and nu is the frequency, the 20th point. So H you can now find out. Energy, you know, energy we have calculated there among those quantities, right? Fourth point was energy. Then frequency is this. From here it is frequency. So when we write it down, Planck's constant, this H will be energy divided by frequency. So for H, what is energy when we are talking about energy? So energy, when we are talking, the SI unit for the dimensional formula for energy is ml square t to the power minus 2. And for frequency, we already know this is t to the power minus 1. So what is left? This becomes m l square. See, 1 will go up, t to the power minus. And the unit is joules per second. This is not very important, Planck's constant. Means the formula is not very important, but this writing part is important because energy is there and frequency is there. Write it here. And all of you, when you will come to 17th point, you will tell me what is the answer. Till where you have written? Stress you have written from here. Start writing from here. I'll scroll it slowly and answer the surface tension part when it will come. See, force by length. Yes, Sabiha's answer is correct. See, force is M L t to the power minus 2. And what is length? Length is just divided by L. So, see, length will be cancelled. No, why t to the power minus 1 is coming? Force is mass into acceleration. So, t to the power minus 2. So, this is m into t to the power minus 2. And Newton per meter will be the length. See, last three quantities, these are from your thermal physics that we'll be doing in the second book. So temperature, I have told you, temperature is a fundamental quantity, so it has no formula. Only the derived quantities will have the formula. Now see, for temperature, either theta is used or Kelvin directly is used. SI unit is also Kelvin. All right, so whenever in the formula we'll be having temperature, we'll be using either K or theta. We'll prefer to use K, but in some books, some authors use theta also. Coming to heat energy. Heat energy, I have told you all the types of energies have the same formula. So this will also have m L to the power 2, T to the power minus 2 as the formula and joules as the SI. For all the energies, this is fixed. Potential energy, heat energy, kinetic energy, any type of energy that is existing in the system, entropy or internal energies, all the energies or work done have the same dimensional formula. When we're talking about specific heat is this S. See, let me tell you what is this first. This is the last quantity. Then we'll just see the questions only now. Delta Q is the heat energy. M is the mass. S is the specific heat. This is the specific heat. And delta T is the temperature. Fine. Now see, if we have to write the S will be equal to delta Q divided by M into delta T. Now put the formula. Heat energy is the same, that is M L square T to the power minus 2 divided by mass is M. Temperature is K because itself is a fundamental quantity. So what is the dimension? What are the dimensions? See, mass will be cancelled. So M to the power 0. Length L square. Time T to the power minus 2. And temperature, when this will go up, this will become K to the power minus 1. And the SI unit, this is joule per kg degree Celsius. This you can ignore also for this, but this specific, out of all these, surface tension, stress, strain, modulus of elasticity, these you'll be able to do. And those initial table which we did, these come a lot in the exam. Complete this table, write it down. Class, you have your after class assessment right now. So just write down this question. The solution, I'll discuss it in the next class now. That completes with writing down of dimensional formula. Then now we'll start with writing the actual formula using dimensional analysis. So you all can leave now, but log into your portals and appear for your after class assessment. Rest of it we'll discuss in the next class now. And after Ramzan, your timings will also be changing and duration will also increase. But for the time being, right now only we have the class. All right, any doubts if you have, you can contact. Otherwise, you can. All right, thank you so much.
Thank you, ma'am.
Thank you, ma'am.